You know how your email just knows what's junk? Or how a streaming service seems to read your mind on a Friday night? Well, it's not a lucky guess. Today, we're going to pull back the curtain on the powerful machine learning technique that makes it all happen.
So, what's really going on here? At its core, this whole thing is about making decisions by sorting information into, well, neat little piles. It's all about answering the kinds of yes or no questions we run into every single day.
I mean, just think about it. A bank gets a loan application. The big question is, safe or risky? Your inbox stings with a new message. Is it spam or not spam? You're scrolling through a streaming service. Watch or skip? These aren't just wild guesses. They're super calculated predictions. So really, how do they make these calls so fast and get it right so often? Right, so it's not magic. It's something called classification, and it's a huge deal in data science. We're basically teaching computers to spot patterns in the messy world of data and use those patterns to put new things into the right buckets. Okay, so how does a machine actually learn to do this stuff? You might think it's super complicated, but it really boils down to a pretty straightforward two-step process. Let's break it down. First things first, let's get a handle on what we're talking about. Classification, at its heart, is about building a model. You can call it a classifier that predicts a category, or what we call a class label. The whole point is to take some brand new piece of data and confidently say, yep, this one goes in the safe pile, or nope, that's definitely spam. And here's the game plan, laid out nice and simple. Step 1 is the learning step. This is where the model does its homework. We feed it a training set. That's just a bunch of data where we already know the right answers. See, that's why it's called supervised learning. We're literally supervising the machine, showing it what's what. Then comes step 2, the classification step. This is the final exam. We test the model on data it's never seen before to see if it actually learned anything. If it passes, boom, it's ready for the real world. Okay, so one of the coolest and honestly most intuitive ways to build one of these classifiers is with something called a decision tree. It's an awesome way to actually see the decision-making process in action. Seriously, just think of a decision tree like a game of 20 questions. It starts with a big, broad question, and then, depending on your answer, it asks a more specific one. Each question splits the data and narrows down the possibilities until you finally land on the answer. So to build this tree, we start with a labeled training set. Just like this one right here. We've got data on past customers, their age, income, if they're a student, and that last column, buys_computer, that's our class label. That's the answer the machine is trying to learn how to predict. And this right here is the million-dollar question for the algorithm. Where do you even start? I mean, you've got all these attributes: age, income, student status, credit rating. Which one is the best first question to ask? Which one will get us to the right answer the fastest? Well, the algorithm doesn't just guess. It uses a clever metric called information gain. It literally calculates which question will do the best job of separating the yeses from the nos. And as you can see from this chart, asking about age first gives us the biggest reduction in confusion. It gives us the most bang for our buck, for sure. And here's what that looks like in practice. Our tree starts with age right at the top, the root node. The data gets split into 3 branches: youth, middle-aged, and senior. And check this out. The middle-aged branch is already perfectly sorted. Every single person in that group bought a computer. That's what we call a pure group. It's the perfect outcome. The other branches, well, they're still a bit messy, so they'll need a few more questions. Okay, so let's dig a little deeper into this whole art of the split. What do we even mean by the best question? It's all about making the new groups you create as pure as possible with every single step. So, a group is pure if everybody in it belongs to the same class, just like our middle-aged group, where it was 100% yes. The algorithm's whole mission is to keep asking questions until every single branch ends in one of these pure groups. This slide shows the difference perfectly. A good split, over on the left, takes a messy, mixed-up group and creates subgroups that are way cleaner. In data science, we have a name for this messiness or uncertainty. It's called entropy. A bad split on the right, well, it doesn't really clean things up much at all. The entropy is still high. And that brings us back to information gain. It's not just some buzzword. It is a precise mathematical formula that calculates exactly how much a question will reduce that overall messiness, that entropy. So the algorithm, in this case one called ID3, just picks the attribute with the highest information gain every time. It's guaranteed to make the most progress possible with each split. Now, decision trees are fantastic and super easy to understand, But they're just one tool in the classification toolbox. There are other really powerful methods that machines use to sort all this data. For instance, you've got Bayesian classifiers. These use probability to figure out the most likely category for something new. Then there are rule-based classifiers, and they do pretty much what you'd expect. They build a set of simple if-then rules from the data. Like if age is youth and student is yes, then Bayes-Coutier is yes. Super straightforward and often really easy for us humans to read and understand. Okay, so we've gotten pretty deep into the how, but let's pull back for a second and talk about the why. Why is this one technique so incredibly important in our world today? It's because classification is, well, it's everywhere. It is the engine running behind the scenes when your credit card company spots a fraudulent charge. It's what powers the targeted marketing that decides which ads you're going to see. It's even used in medicine to help doctors predict patient outcomes based on their data. It's a real workhorse. This quote from the source material just hits the nail on the head. We're sitting on these mountains of data, and they're filled with valuable hidden patterns. Classification is the key that unlocks all that hidden information. It lets us turn all that raw data into smart, automated decisions. So the next time your phone automatically sorts your photos into folders or your bank sends you a fraud alert, you'll know what's happening under the hood. It isn't magic. It's just a logical, step-by-step process of sorting the world one question at a time. And now that you can see the pattern, the real question is, where else do you see it shaping your world?